Okay. Rachel, how does that look as far as screen share goes?
Looks good to me.
Okay, awesome. Go into full screen. Okay, I have 18 participants logged on. Okay, Rachel, are you ready to get rolling?
Yep.
Okay, awesome. Well, hi, everybody. Thank you for joining into our Unpacking Embodied Carbon webinar. So we'll just get moving right along here today. First and foremost, my name is Gina McCracken, and I manage the Climate Action Collaborative for Eagle County Communities, where I facilitate a stakeholder group of over 30 partner organizations towards implementing the Climate Action Plan for Eagle County communities. Okay, so just a little bit of background on the Eagle Valley Green Building Group, and then we'll jump into an introduction from our presenter here, Rachel. So I facilitate the Eagle Valley Green Building Group, which is an Eagle County chapter of the USGBC, the United States Green Building Council. For those that might be unfamiliar, USGBC administers the LEED certification program. We've been hosting building events in the community for several years now. We usually host 4 events per year, some of which are in an online format like this, where we're providing learning opportunities via webinar format, some of which are in-person events focused on the Eagle River Valley and beyond. So if you have topics that you'd like to see covered in 2025 or into the future, let us know. We're happy to collect feedback on green building learning opportunities for you all. And stay tuned for 2025 events. Just as a couple reminders, you can receive 1 general GBCI continuing education credit for attending this webinar. So if you would like to receive credit for attending this, please email me or chat me if you're comfortable with it, your name and your GBCI number to receive that credit, and I will pop my email into the chat in just a moment. And then as Rachel is moving through this presentation, you're welcome to contribute your comments or questions into the chat, and I'll help moderate that. And then we'll reserve some time at the end of the webinar to review your questions and save time for some Q&A. All right, turning it over to Rachel Meyer to present on embodied carbon.
Awesome. Thanks, Gina. So hi, everyone. I'm Rachel Meyer. I'm a senior associate at Lotus. And as you can see on the screen, I'm our team lead on public sector greenhouse gas emissions inventories. And for those of you who don't know Lotus, Lotus is a Denver-based women-owned sustainability consulting firm. We work on projects mostly with the public sector, although we do a little bit of work also with the private sector. But we do all sorts of sustainability planning and climate action planning type projects. A lot of them based here in Colorado. So today, what we're going to do is a little bit of an introduction on greenhouse gas inventories, and then dive in deep into embodied carbon inventories, and then a project that Lotus did with Pickens County, so your guys' neighbors to the west, around embodied carbon of residential homes in the county. So Gina, if you want to go to the next slide. So a brief overview of greenhouse gas emissions inventories, just so we're all on the same page. So there are many different types of greenhouse gas inventories. The most common that we've all probably heard of is a community-wide greenhouse gas emissions inventory. So that's taking a boundary like a city boundary or a county boundary and looking at emissions that happen within that specific boundary. Similarly, we've got a municipal or a local government operations inventory, and that looks at a specific local government like Town of Vail or Eagle County and any of their specific operational emissions. So their facilities or the buildings they own and operate, their fleet vehicles, any facilities like a wastewater treatment plant or a landfill they own and operate, all of those emissions totaled together. And then similarly, company or an organizational emissions inventory, that's mostly the private sector side. So looking at like a Google or any kind of company's inventory and looking at all of those same or similar sources of owned buildings or leased buildings and own fleet and equipment and employee commuting, things like that. Then we have kind of the biggest inventory we can do, which is a consumption-based inventory. So looking at the little graphic on the screen, the consumption-based inventory is that big white circle that also encompasses that little green circle in the middle. And the smaller circle that has the green and red in it together are those traditional sector or community-wide inventories. A consumption-based inventory takes a look at all consumption happening within a community and going all the way back to calculate the emissions of sort of the life cycle or the manufacturing, the processing, the creation of the materials to be consumed, then the consumption of those materials, and then also the end of life of those materials. And then finally, we have embodied carbon. So embodied carbon is sort of a subset of the consumption-based inventory, really looking at specific materials or like a building itself, looking at the whole kind of life cycle of that. We'll go into that in detail in the next slide. So Gina, if you want to go on to the next one. So what is embodied carbon? Otherwise known as life cycle emissions. And we look at this either at the product level or at the building or a vehicle, sort of a product's life cycle. So all the way from the cradle to the grave, as you see on the screen, defined as the emissions generated throughout a material's whole life cycle from cradle to grave. So we go all the way back to the start where a material is manufactured or mined, or if a tree is felled to make wood or boards, that start of life, that extraction of materials, then the processing to form it into the material that it ends up being used as, then the transport to wherever it gets used, so that part of its life cycle, and then all the way to the end where it gets disposed of in the landfill. So the trucking of it to the landfill and then the disposal of it in the landfill. And embodied carbon emissions, according to the US EPA, account for about 11% of global emissions every year. Do you want to go to the next one, Gina? So this is just a different, kind of more visual look at a whole life cycle of a product. So we'll start all the way to the left side in that product phase. So we break this down into different little phases and then add it all together to calculate embodied carbon. So on the far left, our product phase, which is the cradle or the start of life. That's going to be raw material supply and transport, the manufacturers. So if it's, a steel beam, it's the mining of the iron, and then the forming of the iron into the steel beam. Those phases, or the product phase, accounts for between 65 to 85% of total embodied carbon emissions for a given product. Then we move on to the construction phase, construction being transporting that material in its sort of final form to the site or to wherever it gets used. And then also the emissions associated with putting it into whatever the final form is. So if it's being used in a building, the emissions used to install it in a building. That's anywhere between 6 and 10% of a material's total embodied carbon emissions. Then we have the use and maintenance phase. This is mostly a phase that we would look at for a building or a vehicle. It's going to be the use of a product. So this is more applicable in a house. So if you look at the operational energy use in a household, water use, any fuel used to repair or refurbish a material within the house. The use and maintenance phase, then between 8 and 15% of a product's embodied carbon emissions. And then finally, that end of life at the right of the screen. So the deconstruction or demolition of a building or product, and then the trucking of it to the landfill. And if it does decompose in the landfill, if it's like boards or wood, the emissions associated with that decomposing in the landfill. So that end of life is anywhere between 3 and 15%. The higher end of that being those more natural materials like wood that actually do decompose in the landfill at the end. So if we add all of that together, all the emissions throughout the course of that product's life, that's our embodied carbon emissions. So if you want to go on to the next slide, Gina. Now we'll pivot a little bit and talk about that Pickens County analysis that we did. So we'll back up a little bit and go back to 2019 when Pickens County declared a climate emergency. And they passed a resolution to formally adopt that climate emergency. And so that resolution states, as you can see, that the county must mitigate carbon emissions, and they need to do all of those bullets on the screen. So revise the building code to work towards net zero homes, revise the land use code to encourage more renewable energy, improve energy efficiency, more renewable energy, improve the diversion of construction and demolition waste and debris, support regional mass transit, and then electrify the county's fleet. So the bullets that are really important to us in this study are kind of those first four, especially that fourth one. Pickens County's landfill is shrinking in capacity as more and more waste is deposited in the landfill, and it's getting closer and closer to capacity. And construction and demolition waste tends to take up a lot of space. And so if we're building a lot more homes and wasting more materials, that shortens the lifespan of our landfill. So they were really particularly concerned about that as well. So if you want to go on to the next slide, Gina. There were three real phases here to this analysis that they wanted us to figure out for them. One was operational carbon emissions from residential homes and from different tiers of residential homes. During COVID, Pickens County, I think like a lot of other mountain counties like Eagle County, Summit, Route, they got a lot of requests for building permits. And the houses they were building were not your traditional 2,000 to 3,000 square foot houses. They were 5,000, 10,000, 15,000 square foot giant houses, which use a lot of energy and a lot of different types of energy that aren't used in an average house. So like a lot more appliances, a lot more technology, a lot more recreational uses like hot tubs and other kind of sources of external energy use. So they wanted to understand sort of how that plays out in those larger houses. Then they wanted us to look at the embodied carbon emissions from those newly built homes. And then finally, the additional impacts from all of this, from the construction and also the upkeep of large homes, because unlike average homes, large homes tend to have a staff that upkeep them, since homeowners are typically using them as a second, third, fourth, fifth home. And they're only there for a really short time during the year. And there's a lot of emissions then associated with the upkeep of those homes. So we had sort of all three of those phases. And starting with that first operational carbon emissions phase, looking at those little houses on the screen. So your average energy used in a 2,000 square foot home is that one on the left. And in a 10,000 square foot home, it's almost 3 times the amount of energy used compared to a 2,000 square foot home, which also means it's about 3 times the amount of emissions associated with that, which is concerning if they're building a lot of those houses and they're trying to actively reduce those emissions. That's not as in line with those goals. So Gina, if you want to go to the next slide. Then we took a look at embodied carbon. So what we did, we worked with the county to pull, I think, a year or two's worth of new building permits that they had received. And we took those permits, understood sort of where in the county they were located, most of them in the unincorporated part of the county, how large they were, what materials they were requesting and what they were using. So we used work request orders, I think, to understand all of the materials that we needed or were needed to then construct the house. We also tried to look at where those materials were coming from. We did a lot of interviews with builders and contractors in the county to understand where they were picking up materials and where those materials were originally sort of coming from. We had to understand, how much was trucked to the landfill, how much was wasted in the process, understand the amount of fuel used to build different tiers of homes, the types of equipment that were being used. So a lot of research and informational interviews and discussions with contractors and builders to understand how this process works. Then we were able to use just sort of energy use intensities from that first analysis to understand, based on size of building, how much energy is being used in that operational phase of the building's life cycle. And then finally, what is being trucked to the landfill, and then how much of it. So we were able to do that for a set of houses, and we added all of those embodied carbon emissions together. And from that graphic on the screen, you can see those sort of 4 phases of a product's life cycle. So the product phase at the far left, that being about 50% of embodied carbon emissions from those newly constructed homes. The construction phase, or the transport of finished materials and building construction, being about 2% of the embodied carbon emissions. The operation of the house is about 48% of emissions then. And finally, the end of life, the demolition or deconstruction, the hauling of the debris to the landfill, and then anything that does decompose in the landfill, really the smallest part of that. And so that's about 0.3% of total embodied carbon emissions. Yeah, so you can see kind of the larger the home, also we found the larger the embodied carbon impact, just more materials generally needed to build those homes, especially the larger the home, the more custom the home. So you'd have walls of windows, or you'd have really like specific types of products in the house, a lot of like wood beams or steel beams, and that also increases your embodied carbon emissions. We found that a lot of the steel was coming from China, and so that is going to really increase emissions, that if you have to ship that from China to then be, brought by rail or truck out to Colorado, it's a lot of impact on emissions. So if you want to go on to the next slide, Gina. We also broke this down by type of material. So we looked at concrete, glazing or windows, ornamental steel, so steel, like some structural steel, but also a little bit of those like steel beams that are kind of for design. Finish woods, rebar steel, framing steel, plywood, paint, drywall, lumber, insulation, and then masonry or bricks. So looking at just the materials on the screen, you can see that the upfront, so that product phase emissions, these are the different product phase emissions of these materials. So concrete and glazing or windows, really heavy in the product phase. Steel, pretty close behind. All of those require a lot of energy to form them into the material that they become. Lot of high temperatures to really melt everything into a steel or a window. And again, the larger the home, then the larger the upfront carbon impact. The other interesting thing we found was that some of these houses have 2 or 3 basements, which is leading to a lot of concrete use to frame those in underground, which was also helping to increase some of those emissions. So Gina, if you want to go on to the next one. Then we also try to calculate an embodied carbon value per square foot. So we measure this on a metric ton of carbon dioxide equivalent and per square foot. Because we knew the square footage of the houses, we bucketed those houses into sort of a more average household size, a medium to large household size, and then a very large household size. So those ranges being 4,000 foot and below, 4,001 to 8,000 feet, and then above 8,000 square feet. You can see the values on the screen there. With that product phase, the tool we used called the Embodied Carbon in Construction, there's another C, it's called the EC3 tool. They are able to pull what are called environmental product declarations for those materials like concrete, glazing, ornamental steel, stuff like that. And they give you 3 different values for the embodied carbon in the product phase. So conservative, meaning 20, only about 20% of the companies that make the product are able to achieve a really low embodied carbon value. The achievable being about 80% of companies can achieve a lower carbon value. The average is then averaged between them. And so from that, you can see that again, about the larger the home, the larger the average embodied carbon value per square foot. And anything above 4,000 square feet has about 20% higher values per square foot. And even 4,000 feet we thought was a really large house, even for like a general person's house. But that was sort of the low end for the new permits we were finding through our analysis. So Gina, if you want to go to the next one. So then the last phase of this analysis was the other impacts from the management and the construction of those large homes. So this was sort of a separate analysis where we did a really big employee commuting survey. We were able to ask, Pickens County had access to employee data from contractors to understand where employees were living and then where they were having to drive to do different construction projects within the county for these residential homes. So we ran a really big employee commuting survey to understand how far distance-wise people were coming from, if carpooling was happening, the emissions then from all those miles traveled. The most interesting thing we learned was that there were folks coming from as far as Rifle, Grand Junction, way in the West Slope to come and construct these houses because no one can afford to live in the Pickens County Aspen area, at least those who are working in this construction economy. Similarly for home management, it was a little bit closer in. It was more like Glenwood Springs, between like Glenwood Springs and Rifle, where they were living and coming from. So a little bit shorter of a commute, but still having to commute quite a bit. So obviously we have our construction economy side, which is that 70% of emissions in that top pie chart, or the 30% of emissions, and then the home management economy being 70%. And then home management being all of the activities associated with upkeeping a house for a given year. So that's going to be like weekly to bi-weekly trips to mow the lawn. It's going to be trips to clear the snow in the winter. We found that during the like 2 or 3 week time period when some of these homes are occupied, it's upwards of 30 trips during the whole course of that time to run and grab groceries, to run and pick up them from the airport, to run them to different places. The like prep to get the house ready for them to be there. Lots and lots of trips. And when people are starting from, Grand Junction and Rifle to make that many trips, it adds up really, really quickly. So we learned that. And then we also were able to divide them up into HOA properties versus just one-off sort of large single family homes, since we found that they were in both locations. Those large single family homes that aren't associated with an HOA are most of those emissions then at 81%, and only about 19% we found were within HOA properties. And the emissions we analyzed within those two economies were commuting emissions, like I mentioned, fuel used on site, so like lawn mowing, snow blowing, in the construction economy, whatever fuel they were using to do the constructing of the houses, and then any waste generated in the process. So the other thing we found was from home management, there's a lot of yard waste created, and yard waste does decompose in the landfill, and that also adds then to that big 70% wedge of the pie chart up there. So another really interesting thing that we found. And a stat I will leave you with for this part When we did that commuting emissions analysis, we learned that it was about 53 million miles traveled were just to do that construction and the home management economy. And in comparison to the whole of Picken County's inventory in 2019, I think it's about 25% of their entire annual vehicle miles traveled is just to construct and manage these large homes. So if you want to go to our next slide, Gina. The last part of this then, after we crunched all those numbers and wrote up a big report, we had some recommendations for the county going forward. We broke this up into practices or actions and then policies. So in the practice areas, we have reuse and salvage building materials as much as possible and try to incentivize that or, force that if possible. Involve the architect and structural engineer at the onset and really work to make sure you're only purchasing specifically the amount of materials needed to build the home, not excessive amounts that then get wasted and brought to the landfill. And at the start, also with that architect and structural engineer, seek out those low embodied carbon materials and use those environmental product declarations to look for the better lower embodied carbon materials to use for the whole project, especially like concrete, steel, glazing, and wood. And then within the policy realm, define environmental performance indicators. So within codes or policies, define what those values should be for the product phase of those different products. Facilitate partnerships between manufacturers of low embodied carbon materials and local contractors. So as the county kind of start that process of getting people to talk to each other and work together on these projects. Develop a contractor bidding process that allows selection based on the home's embodied carbon emissions. So estimate that at the outset of the project and then like assigning a point value for that. Identify embodied carbon goals for the residential sector. So now that they have that information, the county can go ahead and set specific goals for embodied carbon in residential homes, and then develop a net zero embodied carbon building policy to then force people to start working towards making net zero buildings in the county. I think that's it.
Awesome. Thank you so much, Rachel. We do have a few questions that folks populated into the chat, so I'm happy to read those off to you. Okay, so did the Pitkin County study include embodied carbon from appliances or mechanical systems installed in the homes, or just operating emissions from those appliances?
Just the operating emissions. We just had sort of like the structural amount of materials for the buildings. We didn't have anything like, number of TVs or number of fridges. We didn't get into that level of detail. It was just sort of the structure of the building.
Thank you. Next question is, for the embodied carbon per square foot slide, is that pounds of carbon or metric tons of carbon?
Great question. That's metric tons of carbon.
Another question we have on here, did you consider vacation rental impacts for the homes in the home management economy or in any way?
That's a good question. We didn't really include vacation rentals. We didn't have great information on that. And Picken County was mostly concerned about these new houses that were just going to be lived in for 2 or 3 weeks, maybe more than that. But just these newer built houses that were mostly meant to be second residences or however many of residences. So we didn't get into quite the vacation rental detail. I think that'd be really interesting. I think it would, especially on the like home management side of things, it would probably reflect similar amounts of emissions just for the amount of cleaning and stuff that would happen as a result of using those homes. But that's a really really interesting thought. Yeah.
Yeah, great question. Okay, last one that was populated into the Q&A. Did you all consider all the traffic during the commute to build the large homes? Lots of idling time on Route 82. So I guess were traffic emissions considered?
We did not include traffic emissions. We only had information about, where the construction employees were living, where they were going, and then how often they had to be at the site, and also how much of the year they were at the site. So if a home was built in 6 months, it was only 6 months of the year, sort of thing. We just had to sort of guesstimate the route that they took, and we don't have traffic specific data, but that would be also really important to consider if there's a lot of idling happening, especially in the winter.
Yeah, a lot of layers of data you can bring into an analysis like this. It's hard to really capture the full impact of what we're talking about here. We have to bake in a lot of assumptions into studies like this. Another question is, how can we find low embodied carbon building materials? It's a great question.
Yeah, that's a really good question. So a lot of these environmental product declarations are just freely available online. You should be able to just Google like environmental product declaration for whatever, like ready mix concrete. You should be able to find different companies that should pop up. If not, I can put the link to the EC3 tool in the chat. It's a free tool, and that's where we pulled a bunch of our information from. Companies upload their environmental product declarations into that tool. So you should be able to pull any of that information. So I will drop that in the chat.
Thank you, Rachel. Okay, we have quite a bit of time left. So if folks that are attending want to populate any questions into the Q&A or pop them into the chat, I can also allow speaking privileges if anybody enters anything into the chat. While we're waiting to see if other questions come forward, I did have a question mostly related to some of the key policies that you noted. Do you know if any communities around the country are implementing any sort of embodied carbon policies at the building code level? Or were those key policies pulled from examples across the country? Or is this still a space where there's mostly ideas and less implementation?
Yeah, it's mostly the latter. We actually had to pull like kind of globally some of those policies. It's still very new in the US, but some of those more progressive places are starting to think about it. In California, especially, they're starting to think about it. So it's still a space where there's learning and growing, but even here in Colorado, I think the conversation's really starting. I've heard places on the Front Range thinking about it. Denver, Boulder's open space department, especially, they're all starting to think about what that would look like to implement a policy. So I think within the next probably 5 years, you'll see a lot start to happen.
That's great to know. And with that, we have another question. Is it correct that larger homes were more carbon intensive per square foot versus smaller homes? One would think they may be less intensive, but are higher end materials more carbon intensive?
Yeah, so it's probably not universal across the board, but what we were finding with the larger homes, especially ones with some of those heavy energy uses, it was ending up being more a higher energy use intensity per square foot than those smaller houses.
We'll see if other questions come in. I do have a couple more slides after this. I just wanted to contextualize the presentation in some local initiatives that are going on. So we'll hang out for a little bit longer to see if other questions come in. And then I just have a couple local initiatives to share about that kind of point to some embodied carbon initiatives going on across the community. Here's another question. Was the EUI difference more due to operational emissions or life cycle?
So we had those two separate. The energy use intensity was specific to just the energy use in the buildings. We didn't factor in the embodied carbon. Um, they're kind of two separate. I mean, there is the operational kind of baked in to that EUI per square foot value that we saw on the slide. But they were like two sort of separate analyses. So the EUI, the operational EUI is mostly due to those heavier external or just the amount of tools and technology and stuff within the building. And then on the life cycle or the embodied carbon emissions, most of that EUI value was actually that first phase, that product phase, and just the quantity of materials needed for the different buckets of square footage. Although operational does play into it as well.
Yeah, speaking of which, I was really fascinated to see that the embodied carbon from materials sourcing and processing and extraction was more carbon intensive slightly more carbon intensive than the operational emissions. So it definitely points us in the direction of, retrofitting existing buildings as yet another key opportunity for emissions reduction rather than going straight to new builds. Okay, we'll hang on to see if folks have more questions. Okay, I might move ahead and go into my slides, and people online, if other questions or thoughts come forward, you're welcome to continue to populate those. We'll hang on here till 4. So just a bit on local initiatives. So I definitely wanted to contextualize the embodied carbon presentation and what's going on here locally. And while we don't have any local policies that are really aiming to address embodied carbon in big ways, there are some local initiatives that we can look at. So the first of which is the Regional Net Zero Building Code Roadmap project that we have going on. Within this project, we're working with Eagle River Valley communities as well as Roaring Fork Valley communities to roadmap our code adoption process to net zero new construction by 2030. And as a part of that process, we had to determine what attributes are or compose a net zero building. There are different definitions out there. I believe the federal government now has a definition. Other buildings organizations have definitions. But we wanted to ensure that we were in consensus on what net zero means in our community, knowing that our utility, Holy Cross Energy, is well on their way to their 100% renewable electricity by 2030 goal. So within us building our net zero building attributes, you'll see that we determined that a net zero building is a building powered by electricity, using renewable energy from the grid and or on-site generation, has the ability to store energy or shift energy use to reduce peak demand on the electrical grid, achieves energy performance above the base IECC, is designed to minimize embodied carbon, and is EV ready. So while we weren't able to put a lot of energy and focus into how we elevate embodied carbon impacts into the building code during our net zero code road mapping process, we did come to the consensus on the fact that minimizing embodied carbon is an attribute of net zero buildings, which I think opens up the doorway to include embodied carbon impacts into future code cycles. And that can be, done through requiring that certain materials are sourced from reused materials and other mechanisms that are mentioned. And then another local initiative that I wanted to mention is more kind of on the back end, but here in Eagle County, through our materials management task force, a construction and demolition toolkit is being made to support C&D and waste diversion at the C&D level. And so this toolkit is something that can go out to local buildings workforce that are working on both construction and demolition, and sharing how they can parse out those materials during, namely, the deconstruction process, and then get incentives to bring those to our local recycling facility here in Eagle County. So if that is something of interest to you, I included my colleague's name and email, who's really been heading up that initiative. That resource should be available soon, so feel free to reach out to her with more details or information. But just to say that these are things that we're thinking about here in Eagle County, and while we haven't made considerable strides to address this through code or any sort of policies, it's something that we're trying to get a grasp on first with early adopters, if you will. And finally, just some calls to action for folks that are on the call today. Things that you can do are, I just want to point back to the key practices and key policies that Rachel had shared with us out of the Pitkin study. So think about those key practices and determine how you can put those into practice, whether at your organization or company. You can advocate for adoption of the key policies that Rachel included to decision makers. Discussing embodied carbon at the organizational level and identifying achievable interventions is another way that you can make some changes in this space. And then ensuring that we're sharing this presentation with colleagues. We've been so focused on operational emissions within the building space, which really needs to be tackled first, but embodied carbon is really the next big hairy challenge. And so the more that we're talking about embodied carbon, the more that we can really impact some change here. Okay. We'll hang on for a few more minutes to see if other questions are asked. And Rachel, can I include your email in the chat for folks who may want to reach out with additional questions?
Yeah, you bet.
Okay, awesome. I'll stop sharing for now. Rachel, your email is rachel@lotussustainability.com, correct?
Yep.
Okay, great. And if the remaining folks online don't have any questions to ask, feel free to log off and we'll close out the webinar.